Hello friends, welcome to Padai Book Classes, and in this video we're going to be talking about decimal to binary conversion. It's a very interesting topic, so without wasting any more time, let's just start it. Okay, what are decimal numbers? Numbers which are composed of digits 0 to 9, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, are called decimal numbers. Their base is 10. They are widely used in our day-to-day life by most of the humans. Although it is most widely used number in the world, computers are much more capable of understanding other numbers with different base. The other number systems are binary, octal, and hexadecimal. In this video, we will talk exclusively about binary number systems and their conversion from decimal number system. Decimal representation. Now let's just revise what a decimal representation is. Okay, and let's just take a number 732. So 732 is, let me just quickly change the color of this pink to yellow. Alright, 732 is actually what? It is 7 into 10 to the power 2 plus 30 into 10 to the power 1 plus 2 into 1. Alright, that is how numbers are represented. Let's take another example. 93, very simple number. 9 into 10 plus 3 into 10 to the power 0. Cool. Alright, let's take a bigger number. 43,601 is actually 4 into 10 to the power what? 3, 4. 10 to the power 4 plus 3 into 10 to the power 3 plus 6 into 10 to the power 2 plus 0 into 10 to the power 1 plus 1 into 10 to the power 0. Alright, this is how you usually represent numbers in decimal. Okay, now computers are much more capable of calculating things in binaries. That's why we learned binaries. So let's just talk more about binaries. It is made up of 2 bits, that is 0 and 1. Bit is short for binary digits. The binary system is widely used in electronics and digital systems. Computer source code is ultimately converted into this machine language. High voltage refers to 1 and low voltage is 0. Every kind of data like string and numbers can be converted to binary as we see in future slides. Alright. Now converting decimal to binary. For that you have to first memorize the power of 2. Why power of 2? Because the base of decimal number system is 2 and the base of decimal number system is 10. And the base of binary number system is 2. So 2 to the power 0 is 1. 2 to the power 1 is 2. 2 to the power 2 is 4. And 2 to the power 3 is 8. 2 to the power 4 is 16. And 2 to the power 5 is 32. 2 to the power 6 is 64, and 2 to the power 7 is 128. Alright, this is how you convert decimal to binary. Alright, no, this is not how you convert. You first memorize these numbers. It is important that you memorize this number. Okay, I'm just writing this so that it gets printed on your mind. Now how do we actually use it? Like for example, let's take an example 43. Now you think of a number which is in powers of 2, but it is not greater than 43 and it is the highest power of 2. So we subtract 32 because we cannot think of number which is greater than 32 and it's in power of 32. of 2. Like for example, 2 to the power 5 is 32, alright, and 2 to the power 6 is what? 64. Now 64 is greater than 43, so we cannot take this number. We reject it. We take this number, 32. We subtract this number and we get the result. What is the result? 8, 9. We get 11 as the result. Yeah, I think I did a mistake, calculation mistake. And we have to keep remember that we subtracted the number from the 5th position, which is the 2 to the power 5. So for our final binary number will be on the 6th position. We'll put a 1. Alright, 6th position. We don't know what other values will be. Now 11. Now think of another number which is powers of 2 and is not greater than 11. That is 8. So that is 8 is 2 to the power 3 is ultimately 3. So we subtracted 2 to the power 3, which is 8. So we'll put a 1 at 4th position. See, why do we do this? Whatever greatest number that we are subtracting from the given number, we place 1 at one extra position to the power of 2. Since in this case we subtracted 2 to the power 5, that's why I put 1 on the 6th position. Alright, finally we get 3 and we subtract 3 minus 2, which is 1, and 2 is 2 to the power 1. So we put 1 at the 2nd position. Alright, and finally we subtract 1, which is actually 2 to the power 0. So we put 1 at the 1st position. Finally, the remaining positions will be filled as 0. Now this number is binary. Alright. Now let's check if our result is fine or not. How do we check that? You have to check if this number comes out to be 43 or not. Otherwise, we have done some calculation mistake that we will have to check. Cool. Okay, we have. Okay, let me just change this to red. Okay. So that is 1 into 2 to the power 0 plus 1 into 2 to the power 1 into 2 to the power 0 plus 1 into 2 to the power 1. These are the powers of 2. 0, 1, 2, 3, 4, 5. Now the easier way is that we can take only, we have to calculate this into decimal. We will learn about this conversion of binary to decimal in future classes. Don't worry about that. But for now on, just go on with me. That is 32 plus 8 plus 2 plus 1. I guess we get the result as 43. You don't have to bother about this. We'll learn about this in future slides. So I guess our result is fine. Fine. Let's just talk about another method. So let's just learn about another number, that is 43. Alright. In the second method, we repeatedly divide the number by 2. So we get 2, 21, and the remainder is 1. 2, we get 10, the remainder is 1. We get 2 divided by 5, remainder is 0. 2 divided by 2, the remainder is 1. 2, and then finally we get the remainder as in this case we get the remainder as 1, and then when we divide the number by 2, and this time when we divide by 1, we get remainder as 0. Then finally we divide the number by 2, remainder we get 1. Alright, this is how you used to do repeated division in your primary classes. Now this is the most significant digit in your numbers, and this is the least significant bit. Alright, so that's how we see a number. Now the binary representation of this number is 101011. Alright, this is the binary representation of the number 43. Okay, let's see the next slide. Binary to decimal numbers conversion is comparatively much more easy. You just have to see the weighted score. Like for example, we are given a number as binary number is 11011. Alright, so this is the binary number. I'll write this like this. You just have to see the weighted score. This is the 0th power, this is first, second, third and fourth. So what do we do is we multiply 1 by the 0th power of 2 plus 1 multiplied by the first power of 2, then we 0 multiplied by 2 to the power 0 plus 1 into 2 to the power 3, and then finally 1 plus 2 to the power 4. So what result we get? That's not perfect. So we get is it's 1 plus 2 plus 0 plus 8 plus finally that is 16. That is, so now this is 24, 26, 27. The result is 27. Alright. Okay, let's try another example just to understand this better. Suppose we have given a number like fairly a big number like 1011 0101. Alright, now let's convert this into decimal. That will be 2 to the power, let's just consider only one places, 2 to the power 0 plus 2 to the power 2 plus 2 to the power, this is 2 to the power 4 plus 2 to the power 5 plus 2 to the power 7. Why I'm taking that is because the rest of the values will get cancelled out. 1 plus 4 will be 0 only, not cancelled out. There will be 0 only. So this is 16 actually, 2 to the power 4, and that is 32 plus finally 128 to the power 7. Alright, so what we get is, here is 5, 21 and 32 are 21 and 32. Let me just quickly add this. That's 53. So what is 128 plus 53? That is 11. Carry over 181. So we have the decimal number which is 181. So this number in decimals is 181. Alright, let's move on. Finally, we have binary numbers arithmetic. Now what is this binary numbers arithmetic says is that if we have an expression like this, now this is the sum value and carry. When we add 0 and 1, the sum is 1 and there is no carryover. When we add number 1 and 0, the sum is 1 and there is no carryover. Finally, adding two zeros, the sum is 0 and there is no carryover. And when we add 2 bits, the sum is 0 and carryover is 1. Alright, so let's just take some numbers like for example, let's just take 101 maybe, and let's just for the sake of it add these numbers. Okay, now 0 plus 1 is 1. 1 plus 1 will be 0, but 1 will be carried over. 0 plus 0, 0, and 1 will be carried, and 1 plus 0 is 1. So this is how you add numbers in binary. Alright, thanks for watching this video. Do subscribe to this channel for more videos. Have a nice day.